Let me say something that sounds wrong at first. Some of the worst production failures happen even when your timeouts are configured correctly. Not missing, not infinite, not misconfigured, carefully chosen, reviewed, approved. And still, the system collapses. Today's incident is not about bad engineering, it's about a dangerous assumption that timeouts stop work. They don't. Quick pause. If these real production incidents help you think like an on call engineer, like the video and subscribe. I'm running a 30-day DevOps incident series. People who follow along and comment their thinking will receive a free DevOps simulation ebook from me. All right, let me draw this real quick. We have a client. Client is trying to talk to service A, and it has a timeout of 2 seconds, which is failing very fast. This is how most engineers think about timeouts. If something takes too long, we stop waiting, we fail fast, we protect ourselves. This model feels clean, and it's only half true. We have a client and we have a service A, and we have another service B and a database. In between these, we have a 2-second timeout, a 3-second timeout, and a 5 seconds timeout. Here, no timeout. Every team here picks a reasonable timeout value. Each timeout makes sense locally. No one coordinated them. Distributed systems do not have a single clock. They have competing clock. For example, here 2 seconds, 3 seconds, 5 seconds. That's where trouble starts. When the client timeouts, the request is abandoned, but the server didn't stop. It's still working, it's still holding memory, it's still holding logs, it's still talking to other services like a service B. Timeouts don't cancel work, they only cancel patience. If you look here, from the client's perspective, the request is dead, but from the system's perspective, it's still alive. Now, multiply this by thousands of requests. This is how systems run without obvious errors. Nothing crashes, errors stay low, CPU climbs slowly, everything feels degraded, not broken, revenue leaks quietly, trust erodes silently. Very few engineers don't ask, is the timeout correct? They ask, what happens after the timeout fires? Timeouts without cancellation are not protection, they are load generators. This is day 17 of the challenge. You're on call, latency is rising, errors are low, CPU is climbing slowly, clients are timing out, services are busy, traffic is increasing. What do you investigate first? Timeout value, cancellation behavior, queue depth, downstream saturation. There is no single correct answer here. I care about how you reason, not what you guess. If this episode changed how you think about timeouts, like this video so YouTube shows it to more engineers. Comment your thinking and subscribe because next we'll talk about circuit breakers that trip too late.